Hi, and welcome to Lambda U. My name is Gretchen Hubbard, and I am a Senior Solutions and Support Scientist at LICOR. In this section, my colleague and I will explain the science and best practices behind secondary antibody incubation for your Western blots. Once the membrane is washed after the primary antibody incubation step, it is then time to proceed with the secondary antibody incubation step. Before we talk about the protocol, it is important to understand the purpose of a secondary antibody and how they are produced. Secondary antibodies are generated by immunizing a host animal with the antibody or antibodies from a different species. For example, anti-mouse secondary antibodies are raised by injecting mouse antibodies into an animal other than a mouse. Goat, donkey, and rabbit are commonly used host species for producing secondary antibodies, but other host species may also be used. Secondary antibodies conjugated to HRP bind to a region of the primary antibody that does not interfere with the primary antibody binding to the antigen on the membrane. This secondary antibody is made in a species that is different than both the primary antibody and the target protein. This minimizes nonspecific binding that leads to false positives and high background noise. Secondary antibodies are often affinity-purified to ensure both high affinity and specificity for the primary antibody. Using a labeled secondary antibody can greatly increase sensitivity compared to the use of a labeled primary antibody. Directly conjugated primary antibodies usually only have a small number of labels attached to them. Secondary antibodies are designed to bind to the primary on more than one place on the molecule, which leads to several secondary antibodies being bound to the primary. This results in a 3 to 5-fold increase in the number of labels present and a significant amplification in the signal. Secondary antibodies can be conjugated to a number of different labels for detection, such as enzymes, fluorophores, and dyes. The most common secondary conjugates for chemiluminescence are horseradish peroxidase, HRP, and alkaline phosphatase, AP. In order to detect the presence of the labeled secondary, a substrate must be added. The product of this reaction is photons of light, and the reaction is subject to variability dependent on factors such as time, temperature, and substrate concentration. One way to eliminate the variability associated with chemiluminescence is to use a secondary antibody conjugated to a fluorophore or a dye. When the dye is excited by a light source, such as a solid-state laser, a stable signal is emitted and can be measured by something like a CCD detector. After the final wash, following primary antibody incubation, it is time to perform the secondary antibody incubation step. The secondary antibody should be diluted at the manufacturer's recommended concentration in blocking buffer plus 0.2% tween 20 and incubated with the membrane for 1 hour at room temperature with agitation. If using PVDF, it is also recommended that a small amount of SDS, only 0.01 or 0.02%, be added to the blocking buffer N tween 20. For consistency purposes, it is recommended to use a commercially available antibody diluent, such as LICOR's Intercept T20. During this lesson, I hope I have provided you with some of the information about the science involved in the secondary antibody incubation step and the protocol. Now my colleague Carol will discuss some of the best practices with you.